So one more time, you can't have negative exponents. Those are not considered simplified. So let's first just go through and identify the exponents. One exponent that's missing here is this w is w to the first power. So in this first step, I'm just emphasizing the exponents. Okay, then the next thing that we can do this in a few different, you can do it in any order you want here, but I like to just get rid of my negative exponents right away. So I really like the w to the fourth, so I'm not going to do anything to that. And I like the w to the first power, but the w to the -8, I'm going to cross the fraction bar line to change the sign on the exponent. So this -8, when I move w to the -8 to the bottom, it becomes w to the +8. So all that's happened so far is I've emphasized that there's an exponent of 1 on the w, and my first goal is to get rid of all those negative exponents. These ones are both positive, so I left them where they were. And then w to the -8, I want to cross the fraction bar line to change the sign. Now, if you wanted to, you could expand and make that w times w times w times w times w over and w, 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 and you have 8 of those, cross them off. But if we use a few exponent rules instead, when we have like bases, we add exponents. So that is w to the, that is w to the 5th power. Okay, picture that expanded out, w times w times w times w, and then times w, so we have w to the 5th. And then when we have, I didn't change anything in the denominator. Okay, and then using the other exponent rule, when we have like bases in division, we subtract exponents. So I'm going to take 8 minus 5, and I have w to the 3rd. There are more w's in the denominator, so the w to the 3rd is in the denominator. Again, if you get stuck, as soon as you get rid of those negative exponents, worst case scenario, expand it out and then just start crossing off the things that are alike. All right, so this one right here, I'm going to do the same thing. And there are a few different ways to do this, but I'm going to go with always getting rid of the negative exponents first. So I like the x to the +10, so that's going to stay in the numerator. I do not like these negative exponents, so I'm going to grab that power, cross the fraction bar line to change the sign of the exponent. So the x to the -6 goes to the bottom is now to the +6, and x to the -5, again, cross that fraction bar line, change the sign on the exponent. Okay, worst case, at this moment, if you wanted to expand and write x times x times x, 10 of those out, and down here, x times x times x, 6 of those and another 5 of them, and just start canceling, you could do that. But otherwise, let's use some rules. When we have like bases, we add exponents. So this one here currently is still to the 10th, but 6 plus 5 is 11. Guys, good, picturing that expanded out. I have x, 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 and then another 5 x's across. You count them up, you have a total of 11. Then if you expanded these and start crossing off the x's, there's more x's in the denominator than the numerator, so the leftovers in the denominator. And when I subtract those exponents, 11 minus 10, it's to the 1st power left over there in the denominator. But I don't really need to write to the 1st power, so that's just 1 over x. Okay, in this one, both of the powers have negative exponents, so I need to move both of these across the fraction bar line to change the sign. And since everything moves out of the numerator, we have to remember there's still a 1 there in the numerator. Then x to the -9 moved across to make x to the +9. X to the -4 moved across to make that x to the +4. And then when we have like bases, we add exponents. But please make sure, if you get stuck, just expand. If you expand that all the way out and count, you're going to see that you have x to the 13.